Alright, it's time for the solutions for the last part of the prove congruence using transformations assignment. So you tack this on to kind of review just the basic transformations. So you're supposed to describe the transformation using words and a function. So on number one here, if you have the two shapes, you can draw a line in the middle and it makes a mirror image on both sides. Then that's going to be a reflection. So you should write a reflect. And that line right there has a height of -2. So you're reflecting over the line y equals -2. And the function that will do that for you is xy goes to x -y plus -4, or just subtract 4. So you double this number, and that goes right there. -y plus double that number. 2, this one here is a rotation, and it's a 180-degree rotation. And today's music is brought to you by the Zelda series, I guess. So anyway, so this one is 180-degree rotation. If you were to spin this upside down, it would look exactly the same on the coordinate plane there. And the function that's going to do that for you is xy goes to -x -y. Yeah, you just change the signs on both of the coordinates, and that'll give you the 180-degree rotation. And then on 3, this guy is just the original one moved to the right one. So this is it's a translation, and it's just right 1 unit. And that's the whole words part of it, just translating right 1 unit. And if you want to translate right 1 unit, you have to change all your x values so they're 1 more. So you're going to take x, add 1, and then put y the same. All the heights are the same, so that's going to be it for that one. 4, this one, we have our starting figure down here, and then on the one on the side. The only way you're going to get something like that is through a rotation. If we were to reflect over, it would just be facing this way. It just basically be a flip version of it. Like it's like you're flipping a pancake. You flip it over. Even if we do it this way, it's still not going to get you into a putting something on the side sort of situation. So this is a rotation, and it's a quarter turn, so it's going to be a 90-degree rotation. And this one's starting here and going this way, which is clockwise. So that's clockwise. And the function that's going to do that for you is going to be xy goes to, and you have to change the order of your coordinates, so you get y, x, and you're going to have to change the sign on the second one, so you change the sign on the x's, and that'll do a clockwise rotation for you. And that brings us to the next one. We have our starting figure up here and a figure down here. Now, you could possibly think this is a 180-degree rotation, because you're kind of putting, those are opposites of each other, those would be opposites of each other. Okay, those are opposites of each other, those are opposites. But you have to look closely at your orientation. K is on top on both of them, Z is on bottom for both of them. The orientation is the same between the two, and so that's what's going to let you know that this is just a translation, because translations don't change your orientation. So this is a translation, and to do this is just going left 1, 2, 3, 4, 5, 6. So this is left 6 units, and then we go down 1, 2, 3, 4, down 4 units. And that's the words part of it. If you want to go left 6 units, you're going to have to take your x values and make them 6 less. So I'm going to do x minus 6. And if you want to go down 4 units, all your y's need to be 4 less. So you're going to do y minus 4. And you get that function there. Moving on to 6. This figure, you need to look closely at the orientation. Here we have m to the left of n. And then down here we have n to the left of m. So that's been switched. And you can do that with a reflection if you reflect over. But if you were to reflect over, those wouldn't switch orientation. So m is above k, but down here k is above m. And so this one's not a reflection, it's going to be a rotation. And this one's a 180-degree rotation. And the function that will do that for you is xy goes to negative x, negative y. And then 7, we have our b up here. This one has the same orientation, BR, BR, BH, BH. So the orientation is matching on both of them, which means this is just a translation. And you need to say how much. This is going just left 1 and then down 3. So left 1 unit, down 3 units. So if you want to do that using a function, your xy's are going to shift, so your x's are 1 less because you're going left 1 unit. So x needs to be minus 1. And then y, you need to go down 3 units, so we need to subtract 3 from the y's. And that'll be your function. On 8, we have our two figures and their mirror images of each other. And their mirror images over this line here. So that's why this is a reflection over just that line in the middle, which is the y-axis. So reflect over the y-axis. And if you look at your notes, or if you don't have your notes, you look at this, the coordinates for all the y values are going to stay exactly the same. It's the same height, you're not going up and down at all, it's just staying the same. But all your x's are going to be the opposite of what they used to be. You used to have an x value of -3, now it's positive 3, and that's your whole function. And that is looking like the entire thing.